A standing wave flame tube, also known as a Rubens tube. It's an enthralling physics demonstration apparatus that graphically depicts the behavior of sound waves and standing waves. It was named for scientist Heinrich Rubens, who first displayed it in the late 1800s. This tube is often made up of a long, narrow stainless steel tube that's sealed at one end and has small holes running the length of it. Through these openings, flammable gases such as propane or methane are introduced into the tube where little fires are lit. A speaker or comparable sound source at one end of the tube produces sound waves. The combustible gas interacts with the waves as they pass down the tube. When sound waves strike the gas inside the tube, they form high and low pressure zones. Standing waves, which are zones of constant pressure that do not move, can form as sound waves bounce back and forth inside the tube. Standing waves appear at specified wavelengths. The flames inside the tube react to pressure changes induced by standing waves. Flames soar higher when there's high pressure, and they fall lower when there's low pressure. The flames generate peaks and troughs in the pattern, creating a dramatic visual image of the standing waves. The standing wave flame tube is generally used as a science demonstration or educational tool. It efficiently depicts key acoustic concepts such as resonance, wave interference, and standing wave nodes and antinodes. It teaches students and those who are curious of how sound waves behave and how they can produce specific patterns and frequencies in various surroundings. To display various standing wave patterns, the frequency of the sound source can be varied. By varying the frequency, you may generate different resonant modes and observe how the flame pattern responds and changes. Working with flammable gases can be hazardous, though, so make sure you take proper precautions. Proper gas regulation and monitoring are critical for avoiding combustion dangers. The standing wave flame tube is an enthralling and instructional physics demonstration tool for visualizing sound and standing waves. It provides a hands-on and visually appealing method of teaching and learning about acoustics and wave phenomena. These are Interesting Things with JC.